All right, so let's continue on with this inductive reasoning, this pattern thinking. Okay, so find a counterexample to show a conjecture is false. Why does a counterexample show that a conjecture is false? So a counterexample is an example that shows a statement or conjecture is false. I think I said that like 4 times, right? 3 times. So again, a counterexample shows something is false. So, if something is always true, great, we can believe it. But if you can find one example where it's false, that is a counterexample. And that means that our conjecture would then be false, right? So that's why I said you only need to find one counterexample to show that a statement is false. So here is our conjecture, right? So this is what they're trying to feed us. A polygon with diagonals has 2 fewer diagonals as its sides. So first of all, a diagonal is a segment that goes across the polygon. It doesn't connect consecutive sides because that would be a side of the polygon. So what we're going to do here is I have a link. We're going to go do the link and then we'll write down our results in a second. Okay. So we're going to use this. Let me get there. Okay, so in this activity here, right, this is a quadrilateral. There we go. A quadrilateral has 4 sides. Notice it has 2 diagonals going across it. Okay, so let's use this slider. What about a pentagon? Now, a pentagon has 5 sides, but now, a pentagon has 5 diagonals. 5 sides, 5 diagonals. That's not 2 fewer diagonals as sides. So there we go. We're already done. We don't need to keep going. So if I go back to our notes, that's it. So when the sides were 4, the diagonals were 2. But for a pentagon, when the sides were 5, the diagonals were 5. That is not following this. That's our counterexample, a pentagon. So because we found a counterexample, this statement is false. And we move on. So that's what we're looking for. So I almost think of like, not to, I say devil's advocate, right? You're always trying to, it's like in the court, guilty until proven innocent kind of thing. You always think, oh, this can't always be true. And then if you can't find a counterexample, then you say, okay, well, it must be true. All right. So always be always be a doubter, right? That kind of thing. Always be a doubter. Okay. All right. Last one here. Yes. So test a conjecture. For the conjecture, test the conjecture with several more examples or find a counterexample to disprove. So the first one, a polygon with 4 congruent sides is a square. Okay, so obviously, right, you guys should know this is a square. It has 4 congruent sides, but it also has 4 right angles. So this is a square. So this works. Okay. Now, do you know any other quadrilaterals with 4 congruent sides that are not squares? Well, yes, I do. I know that a rhombus, if you guys know, or a diamond, right? A rhombus also has 4 congruent sides, but it does not have 4 right angles. But this rhombus is not a square because it doesn't have 4 right angles. So this is your counterexample. So your rhombus is your counterexample. And because you found a counterexample, that means this statement is false. Okay, what about the second one here? If a number is a multiple of 9, then the sum of its digits is a multiple of 9. Okay, so let's take a look at some examples here. So let's look at some multiples of 9. Multiple, and then the sum of the digits. All right, so let's go with 18. 18 is 2 times 9. And yes, 1 plus 8 is 9. So that works. 3 times 9 is 27, and 2 plus 7 is 9. That works. 4 times 9 is 36, and 3 plus 6 is 9. That works. Let's do one more in order. Let's do 45. Let me draw this up. Let's do 45 because that's 5 times 9, and 4 plus 5 is 9. Okay, so let's skip ahead a little bit, right? So let's come over here. Let's try some bigger numbers. So let's do 9 times 13. 9 times 13 would be 27, would be 117. And 1 plus 1 plus 7 is 9, so that works. Let's continue to skip ahead. Let's do 9 times 26. That's 54, carry the 5, 18 and 5 is 23, 234. 2, 3 is 5, plus 4 is 9, that works. Okay, let's do one more. I'll bring it up here. I'm not going to bother writing multiple in some. Let's do 9 times 58. 9 times 8 is 72. Carry the 7. 9 times 5 is 45. 45 and 7 is 52. 522. And 5 plus 2 is 7, plus 2 is 9. And that works. So I'm going to assume that because every example I figured worked, that this conjecture is true. And again, really, you should exhaust all possibilities, or you should come up with a fancy method of proving that this conjecture is true always. But again, if you do up to 10 examples, I would be okay with that. All right, great. So thanks for watching the video here, and we'll see you next time.